Hi, my name is Lisa Richter. I'm Director of Industry Outreach and Growth for CSIA. Welcome to the Masterclass. Before we get started, a quick word about CSIA. Probably most of you here are familiar with the association, but if you are not, all you really need to know is CSIA, our mission is to help SIs build better businesses. How do we do that? Well, for starters, we have a team of volunteers who have crowdsourced a best practices manual to help SIs scale their businesses. In fact, the BP committee just released a beta version of 6.0, which is the latest version. CSA also offers a certification program and other resources, including professional development, learning from your peers, and access to vetted professional services companies, including insurance, financial, and legal, who understand the SI's unique business needs. For partner members, CSIA offers an ecosystem to grow your SI programs, understand your customer pain points, monitor industry trends, and share your thought leadership. With thousands of qualified integrators and suppliers, the CSIA Industrial Automation Exchange helps SIs, industry suppliers, and manufacturers connect and do business. For SIs and partners, it provides a platform to support your content and SEO marketing efforts, position yourself as a thought leader, and nurture prospects during their complicated buyer's journey. If you are not currently a member, now is a great time to join because dues are prorated. And therefore, if you join now, you get the rest of 2023 as well as all of 2024 included in the dues and any exchange upgrades. Membership provides you and your entire team a full lineup of virtual events and other resources from accounting to sales to operations 365 days per year. If you are currently a member, thank you. If you just want to get a flavor of CSIA and its members, I encourage you to listen to the Talking Industrial Automation podcast, where CSIA members talk all things industrial automation. It's a great way just to hear what your peers are up to and get to know some of the people in the industry. One last housekeeping note before I turn it over to today's speaker. If you have any questions during the presentation, please use the Q&A feature in Zoom. That helps us stay organized. You're more than welcome to chit chat using the chat feature, but it helps us monitor the questions if they're all in one place. So that Q&A spot is the place to go. Also, this session is being recorded and you will get a link to the recording in the next day or so. At this time, I'm going to turn it over to today's speaker. Sanu, take it away.
Thank you, Lisa. Thanks. Welcome, everyone. Thank you for joining us at this webinar where we are talking about how to drive productivity using smart objects, object-based electrical design software, and that is the nVent HOFFMAN DTM software. My name is Sanu Warrior. I am the product director for DTM software at nVent HOFFMAN, and many of you already, I'm sure, know nVent HOFFMAN very well. We are known for electrification, right? We connect and protect everything that has to do with electrification. There's a whole portfolio of things, but I don't want to do that just for now, and we'll move on from there. As Lisa already mentioned, please ask questions. It'll keep us interactive, and we'll get as much as we can out of it. Lisa?
Oh, yeah, I'm not seeing your screen. I don't know if other people are. Have you gone ahead and shared your presentation?
Let me do that again.
There you go. Awesome. All right, so I'm up. What is the DTM software?
Thanks. Excellent question, Lisa. So DTM software is our process and solution for digital thread, right? Simplifying the electrical engineering process and taking that engineering and connecting it to fabrication and manufacturing to drive productivity. Right? And one of the big things that we learned during the process when we're trying to create the software and work with our partners to enhance it is that the market was requiring simplification of design. There was a disconnect between engineering and manufacturing. And we saw this big shortage of skilled labor, which essentially meant that we need to capture and the internal knowledge in the people, the experts that we have, and deploy that on multiple projects to do more with less, and to solve the shortage of engineers, of course. And overall, our growth is always the key factor here. So accelerating the profitable growth. That is the solution. So DTM software is the electrical design solution, the cabinet design solution for doing your designs simply and faster. Now, one point I do want to make here is that one of the other reasons we started with this as nVent is that as a global company, we're hearing this all over the place, not in just in North America, but across the globe. And since we had enclosure solutions, we have panel shop automation machines, which can automate a lot of the manufacturing processes, industrial cooling, and so many other solutions. The big part that was missing was the initial design process. And that's what we got here. And that's what DTM software is. It stands for Design to Manufacturing Software. Thanks for the question, Lisa. You're muted, Lisa. I'm sorry.
Next question. How does DTM utilize smart objects?
That is the crux of the webinar today, isn't it, Lisa? So yes, smart objects are not a buzzword, right? It's about using an object and so that you can start anywhere in a project. You don't have to start with a schematic or a bill of materials or some specific thing. You can start anywhere across the entire spectrum of what you want to do. And that single object then is also the same, just different views of it. It's just a perspective that changes. So an object in a schematic is just a schematic view or a perspective of it. And in DTM, that single object represents everything. It's the enclosure, it's the bill of materials page, it is a connection line, all that, the wires, everything is sort of put together in just different views. And you're essentially creating a single source of truth. And that is how it is creating or utilizing smart objects. So you have this object-oriented technology. That means that you're not having to manage 15 things for one object. A circuit breaker could be the same in a single line drawing, in your power distribution drawing, in your motor control drawing, in your bill of materials or your connection report or your terminal drawings. You can have hydraulics, pneumatics connected to everything. You have a cabinet layout in both 2 dimensions and 3 dimensions. All of that put together is just one object. And that's how we use smart objects so you can make your life easier and save you time.
Ready for the next question?
I am.
Okay. How does the DTM software help in the process of design to building a control panel?
That is a pretty in-depth question. So let me try and summarize that a little bit. But before I answer that question, let me walk back just a second to sort of lay out the groundwork. Is that when we started looking at this, I mentioned earlier, we are hearing from customers everywhere on what they require. One of the pushes that we needed or customers needed to do right after the pandemic, or even before that, but after the pandemic, it was a bigger push, is that customers wanted to go, the industry wanted to go to more automated manufacturing. And what that meant is there's someone's on a journey, they're in manual and process today, and they want to go to either semi-automatic or fully automatic manufacturing processes. And there came the challenge is how do you automate if you don't have the data to automate? As soon as you start automation, you realize that you need specific design data. That design data needs to be accurate, right? Where a hole might be on an enclosure needs to be correct for you to go put it on a machine that can drill it. Or your wire sizes and lengths need to be accurate for you to go cut the wire using a wire cutting machine. Or the labels need to be accurate to print the labels directly on the product or etch it or cut the DIN rails, so on and so forth. So many things we can do. And that's when customers realized that they needed data. So what we did was we took that information and we put that in this digital thread format. Essentially what we are saying is, and what we came up with the solution, if you can do your engineering with this application correctly, what we create is a digital twin, and it connects your entire process through the digital thread. That means you can use the same data from engineering to drive procurement or on the other reports and assembly processes like enclosure modification machines and cutting machines. You can drive that automation directly from the same digital twin, printing and labeling, wire processing, all of that. And a lot of these machines we already have as an offering from nVent HOFFMAN as well. Uh, Another step to that was, okay, that's great, you have automation, but if you cut the wire to a certain size, then I need to tell somebody how to wire that, how to utilize that length to wire it correctly. So it was not just about improving consistency, but it's also about reducing the errors and ambiguity. And for that, what we created was a way to take that same digital twin data that we create in engineering and drive build process. So basically give step-by-step instructions for wiring, for assembly, for testing, as well as give enough information that you can troubleshoot and support your after sales process from that same engineering documentation. So I think initially I mentioned that we are talking about the one single source of truth. That's what we're talking about here as well. That's the digital twin. So that's sort of the background of how we got here and what we do. Now, how this helps, so to speak, is you essentially are in two areas of engineering and manufacturing. One is the initial part of engineering. Then second is taking that engineering data and driving manufacturing. And then we talk about what are the benefits of it. So if I take a look at that, right, it is about smart 2D and 3D panel design. So we enable that. So you don't have to learn a full three-dimensional software for you to have form, fit, and function. You can work in both 2D and 3D. So it makes it easier and faster to get started and simpler to use. Other part of that to make your life easier is a powerful schematic creation process, which is automated, active and passive design rule checks that help you prevent the errors before they happen, as well as check for errors if you have done some decisions, make sure that your decisions were right, or at least have a check for it. And also in the background, in the intelligent database of parts, capture knowledge that you might need. For instance, you might say, okay, I want some space around my VFD and I want it to be this for all VFDs. We can set that up inside the database so it has that rule followed every time you do the design. That's an example, of course. And then we take that data, and the software and application helps you take that data and then drive automated manufacturing, do some automated routing so you can improve how to wire, wiring efficiency, and processing of the wires as well. And then same data, again, as I said, enables digital manufacturing. And we are doing that for one reason alone, is to improve your processes for both engineering and manufacturing. Now, what are the after effects of that? And that's what we can discuss as well, is we are talking about a simple, easy to use solution that can help you get out of sort of the AutoCAD process of lines and circles into a smart object, which helps you drive automation, which helps you get away from the manual work on the manufacturing side. So it's sort of a chain reaction that can get you into the industry 4.0 area where you're automating a lot of the manufacturing.
The next question on my list is, can I use AutoCAD and other drawings, as well as how do you talk to automation equipment that might already be on the floor?
Well, that's a good question. And I think it sort of ties in with the AutoCAD challenge. AutoCAD is commonly used. We completely understand. It is probably the largest application used for both mechanical and electrical engineering. Mechanical is, of course, reducing, more and more people moving to 3D design. On the electrical side, there's still a lot. But that means we need to work with them. And the way we work with that is fairly simple. You can import AutoCAD drawings into the application. Of course, there's no smarts in it because AutoCAD is essentially lines and circles. There might be a block, but it doesn't have any electrical information that you want to do for a digital twin, right? If you want to automate something, you drive the manufacturing process, then you need some more data. So we can import that in and use that as a reference point. We can, but we cannot create intelligence out of it. So for intelligence, we'll have to use the application to sort of mimic what you did in AutoCAD. But there are other ways we can use AutoCAD. First thing is We can use AutoCAD to bring in reference drawings or bring in stuff into the library. So for example, if it's an enclosure or a part, you can bring that into the library from an AutoCAD perspective to provide an outline for it. Another way people use AutoCAD um, or DXF, DWGs, I don't want to say AutoCAD, you can use anything for creating those DWG, DXFs, is to bring that in for a GA. So, you lay that, put that as a background, and you put, the general arrangement drawings can be done as well inside the application, using that as sort of the background for what the machine or the automation equipment it looks like. And so the flip side of it is when you do this intelligent design, you can take that information and export it to AutoCAD as well. So it is not just about electrical design, but about panels, wire harnesses, system designs, pneumatic, hydraulic, PNID, all that can be done inside the same application, the DTM software, and then you can export that into DXF or DWG if you need to share that. Now, other ways to work with other, not just AutoCAD, now I'm sort of expanding on that a little bit by saying there are other file formats that you want to use. There is a complementary API that is involved in the application. So it's an automated design platform. So we can automate a lot of things that come around, and that API is accessible to the customers as well. So they can automate a lot as well. So that means not just AutoCAD, it's about Excel. Can you work with Excel? Absolutely, right? Do you want to export something from the software? Do you want to import something through Excel? That can be done as well. And this is sort of unrelated a little bit, but I did want to answer that something here is that things that we cannot do with AutoCAD, and one of the reasons we move away is configuration management as an instance. It's included with the application. What that means is you can have multiple types of designs and control them in your application. And it's not layers that you can just hide in AutoCAD, because a lot of customers do that. But it is about really truly controlling the configuration. So you are removing it from the software, from the project. So your bill of materials updates, your design updates, your panel updates, as well as controlling variations of it. So a lot of power in there. But to answer the question, AutoCAD, we work with it pretty well.
So I think it's time we see it in action. Can you give us a demo?
Good point. Why don't we try and see if we can do that? Let's see if I can launch the software. There it is. I have a project open already. This is the application. Very simple, easy to use process. All your projects are on your left side of the window. Project
Sanu,
management
is there
window.
any way to increase that a little bit? I mean, on my screen, it looks like itty bitty.
I understand. I understand. Unfortunately, it is as a maximization of screen space, it is small, but I do have a solution for it. So I'll get into that right now.
Okay.
Which is my magnifier. Now, I won't use it all the time, but whenever I'm pointing to something really small, in this case, something like that, how about that? Is that better?
Definitely better.
Okay,
thank you.
Perfect. And thanks for pointing that out. So on that note, the drawings and all the details are in this project management window or the tab that is there. But you can have different types of drawings. The cover sheet is simple, right? You can just click on it, open it. It's just an image of whatever you want as a cover sheet. Single line drawings, control schematics, power schematics, 3D layout, 2D layout. So for instance, let's take a look at one of the examples here, and then I can zoom out. And so that would be my enclosure, right? So I can start here, or I can say, I don't want to do it in 3D. So let's take a look at the three-dimensional object here, and maybe do that, right? That's one of the enclosures, right? So I can see it. Great, that looks perfect in 3 dimensions, very easy to move and work with. But as an electrical engineer, sometimes I'm not very fond of working in 3D all the time. So let me take a look at the same information in 2D. This is laid out flat, just like sheet metal would be. This is the left on the door on the outside, the inside, the mounting plate, the door on the right, inside and outside. So very easy to understand what we're working with. Zooming in so we can see better. We can start here. And I can start doing my design. But I did say earlier, it is smart object. Now, what does that mean, right? For instance, I could have just started with an import from Excel, where I don't want to do any design specifically to connection, or I have a previous project, or I have a list of wires and parts, or I just have a bill of materials that I want to import. I can get started there, where you just load that in, and then that can be loaded inside into the project or exported from the project itself. For this one, of course, is very detailed. It has locations, assignments, devices, pins, wire numbers, so it can import everything in there to get started, including details of what the part numbers are and the wire part numbers are, and so on and so forth. Or I could have just two areas that says, this is my device name and this is my part. Right? That's all. I can import that and get started with that. That's one simple way of getting started. Another way is I have created a schematic. For instance, in this case, I do have a schematic here. It's a simple motor control center, and we'll come back and talk about the schematics later. But let's go back to our enclosure and look at our database here. So the database is on the bottom. There is a significant amount of parts here. There is a database in the cloud as well that we have. But I do want to mention that the database, of course, requires your efforts as well. We are working with manufacturers to add more and more data, more rich data, so you can actually use that for not just simple design, but complex designs and manufacturing. But at the end of the day, when you get the database, you will have access to it, and you can manipulate it and add your information as well, so you can capture the knowledge that you have in there. And we are working with manufacturers to add more and more information as we go. Let's take an example here. Let's take a circuit breaker and talk about what that looks like. And let's close the 3D file for a second, and I will put these windows horizontally here. And I'm going to take this object and take a look. We'll zoom in a little bit here so you can see. It's a simple circuit breaker. It has the contact and the model for it. Now, what does that look like? You can look at in 3D preview here on the right-hand side. You see a model. It's a 3D model. It has some connection points and some mounting locations and a spot for mounting it on the DIN rail. Now, what did I mean by smart object, right? So one thing about it is, if I bring in to this page, I might want to zoom in a little bit so you can see it better. I'm going to bring that object into the schematic. That's a schematic view of it. I'm going to take that into my panel, and then I can convert that immediately into a panel view. So it knows which page it is going on, and it'll drop the right thing on the right page. Same example, right? Let's do a Control Z. Simple Windows commands that you can use to update that, or you can remove it from your operations very quickly. Or let's take a look at a single line drawing, right? I bring that into my single line, and it's a single line drawing symbol, which has one little symbol that connects all the points and has all the information, has a number, so on and so forth. So again, very quick, very easy to work with, but it has the smarts to understand where it is going. And same thing with hydraulic, pneumatic. If you go to a hydraulic drawing, it'll put an hydraulic part, and that's sort of the smart objects. It sort of simplifies the process that you would work with in your day-to-day life. But let's not talk about schematics for now. Let's talk about something else. So I have my parts already. I loaded from Excel. I created a schematic. I want to create my enclosure. Let's start with that. So I have my enclosure, and all the parts are here at the top. I've segregated them into sort of different areas: top, middle, and bottom. And this is what I call a to-do list. It is really, really easy to just take something and drag and drop. And it has smart objects, right? So it will stop me from adding it where it cannot be added, and only let me add it where I have it scheduled to be added. Very easy to just drag and drop. And you notice that the to-do list, one thing is gone from that. That was a switch. Let's take a look at the power supply for our PLC. We're going to add that in there, and then zoom in a little bit and drag and drop. Very simple, drag and drop. I'm reducing my to-do list. It's going down every time I drag something in. I can choose whichever locations I want and start putting that together. My PLC rack is done. It's easy for me to know where to go and add those things. We've been adding it one by one, I think, mostly. So let's do a shift select everything and just drag and drop that. And I'll add some disconnects here. Now you'll notice that the disconnects on the right-hand side have some red blocks here, and you can see those red blocks here in the middle as well. That is a space requirement for it. What that means is this object is set up in the library to say, I need this much space. So if I try to add it on top of something else, it's not going to work. If I try to take it over there, it's not going to work. It's only going to move as much as the space, minimum space requirements are allowed. And that space could be for cooling, for airflow, for space for adding wires, right? You don't have something stacked together, or maybe space for an auxiliary because you plan to add an auxiliary later. All that information can be kept inside and kept inside the library and kept in sync with um, everybody. So you're working off a common field. My VFD, I think similar concept, very easy to manipulate items. So I can just line them up and they lined up. And this red area is a keep out area for your VFD. It's for airflow and so cooling. So it is there. And you need that for VFD. Otherwise, you're going to do a smoke test pretty quickly on that. And that's what happens is when you have smart objects, you can add these rules and regulations in there. When you're doing the design, you don't have to think about it. So when you have a new person coming in, they can very easily work with it. Let's add a terminal block as well here. I'm going to take the whole terminal block and add it in. And as you notice, my to-do list is reduced quite a bit. In the MCC area, I have one of the door objects and all the other external motors, but everything else I'm done. So let's call it done. So in my to-do list, what I've done is I've finished laying out my enclosure in 2 dimensions, of course. So it checked for, okay, so there's space on the left, space on the right, but I did mention 3D. Now, what does that mean? And so we looked at everything in 2 dimensions. Let's see what happens when we do it in 3D. Let's open that same object that we had in 3D earlier that we saw and look at that object in 3 dimensions. And you must have noticed already all the stuff that we did, all the items that we placed in 2 dimensions are already placed in 3 dimensions. And so when it was laying out, it was not just doing a check on the 2-dimensional spacing, but it was checking on 3 dimensions. So you can tell if the door is going to close, what the objects are, what the heights are. And the design can be done both in 2D and 3D, as I mentioned. So you can manipulate or add items in 2D or 3D, and it's the same thing. It just keeps the project up to date all the time. So it doesn't matter where you're working, in 2 dimensions or 3 dimensions, you're just working on the project. 2D and 3D are taken care of by the software, by the application, by the platform. So it doesn't require you to think about it or work through that while you go. And that's, again, simplifies the process. Now, you also might have noticed that there are some objects which have a lot of definition and the other objects which are just looks like blocks with some depth on it. And that's exactly what it is. So these objects, as an example, were created just of a 2D DWG DXF view and given depth. So you can do that as well. So you don't always need to work with step files, but you can also work with detailed step files that have all the contours and all the details. And more manufacturers coming up with step files, but you don't need them to work with the application. You can work in 3D just by giving it a size, X, Y, and Z. So let's go back to our 2-dimensional view just to see something else here. So now that we placed the items, I want to show you something radical. Right? Don't get alarmed, right? It's not, it's no errors, but it is red lines that are going all over the place. If anyone's looked at PCB design, this used to be called a rat's nest for it. And what that means is this is the connectivity between objects. So although you have schematic and enclosures to be separate, the connectivity between the two is always there. So this is telling me what wires are flowing through them or what the connections or the signals are between them. And if I was a better designer, I would have designed this enclosure better. I would have placed these objects underneath this. I would have moved these objects maybe below the other objects so that I can have straight wires going up and down and not have to do these daisy chains all over the place. But since I didn't look at this, I didn't know. So it helps you do the designs better and faster by even giving you information and ideas that you might not be privy to without looking at the schematics. I'll close this because I don't like to look at that very often in the demonstration. And let's take this object and click one button here and see what happens, right? This is called panel auto connect. What that does is what we want to know. And the objects, okay. Um, Give me a second. I did not select the object. Okay. 3 wires were routed, 27 not routed. And it's telling me, oh, there's a lot of issues with your wire routing because it's not able to find a way to route these wires. So it is trying to connect these objects, but it's not able to. So it's basically saying, I'm checking for information, and that's because either my routes are not available or because I have my signals blocked because these are high voltage, low voltage signals. And that's the key point here is that when you start doing these manipulations of the objects, it's also not just checking where the wires are, where the objects are, but it's also checking if the wires can have a route. If I select all the high voltage locations all around the object, but there are low voltage wires, it won't let me route that wire. But if there are available areas that I can route it, then it will do that for me, of course. So what I'm going to do is switch this out for a second, and then we will manipulate this enough so that we can have a design that works for us as we are. In the meantime, while I do that, any questions that are coming up, Lisa?
Actually, this is Bob's job. Do you have
I'm
any
sorry,
questions
yes.
coming in?
Nope, there's no questions yet, Sanu.
Okay, so we'll go ahead and finish that design and work with the project to manipulate that creation process. And we will also then move on to creating our schematics as well. So I'm going to open up my project that actually does all the stuff that we're trying to do. And give me 1 second here, please. And so I'm trying to open the project and it's taking a second to open.
No worries. In the meantime, if anybody wants to leave their contact information in the chat for maybe you're too shy to ask a question here today and you want to follow up with the panelists or the speakers, feel free to do that. We will capture that information to help you out.
Thank you. All right, so let's take that information and do the same thing. So right now I have set these to not just be high voltage, it's also high voltage and low voltage, and now everything is working. So with one click of a button, you're still able to see my screen, right? Lisa? Bob?
Yep,
Yeah,
we're
okay.
good.
All right, perfect. So what we have here is with one button click, we are able to route the wires. So what this is connecting all the wires. And again, the logic is coming from the schematic. I just selected one object, of course. If I select all the objects, it's just a Control A, and then add that in, so select the wires. It's going to take all the wires that are possible and wire all of them together. So all the wiring is done. Now, when we take a look at it, it is showing you information that is much more than just wires. Some wires might not be having this and some might be, but what I do want to show here as a result is when it did the wires, it not only calculated the length, very precise, 5173, probably want to round that up to maybe 21 or 20.5, but it also connected the pin terminals or the ferrules at the end. So on one end, there is a ferrule and the other end it's not. So it's not just doing the wire routing to figure out where the wires are going to go, the shortest path. It's also figuring out how the wire should be terminated. But that's the data you need to send that information to, let's say, the nVent HOFFMAN PWA 6000, the wire cutting machine that can cut the wire, strip the wire, do the end termination, and even create a bundle in a sequence that should be given to the person on the shop floor that can wire the enclosure. So again, very quick, easy to just route everything inside the enclosure. But the one other thing that you will also notice is that something of these blue areas inside the project, inside the duct, that is the fill ratio. So that is how much wire is in here. And there's this dotted line that tells me that if I select wires that are more than that, it's going to tell me, oh, that's too many wires in here. That is the limit that I've set. Now, how do I know that? You can set it as a project, of course, or you can also set it up to be inside your duct to say, okay, my fill limit is 60%. So if the duct is 60% full of wires, stop using that duct. Or give me a warning at 50% and then stop at 60. And you can manipulate that any which way you'd like. So that way you can be sure that your ducts are not too full either. But that's our enclosure design, of course. Again, two-dimensional view that we saw. Let's take a look at the three-dimensional view for it as well. And we will not make it transparent so you can see better. And those wires are routed, again, both in 2D and 3D. So I'm trying to emphasize the fact that it is not just showing you lines and circles, it is showing you much, much, much more than that. Right, so if you move on to the schematics from here, actually before that, one question was earlier was how does it work with machines, right? How do you send something or work with the automated machines in the earlier Q&A? So that's something that I wanted to address here. Is I've laid out the design, I've routed the wires, I'm ready to have some holes punched into these back plates. I'm just going to go and create, essentially selecting the back plate, just create a cutout. And what that means is you are taking the information from this project, and you can very easily either create a file in here or export it to DWG or a DXF file, and it will put all the information here into the project. And what you will notice is what we have is a clear layout of all the objects on the backplate, as well as all the holes that are needed for creating this. Now, the objects that have drill holes defined will have the drill holes, cutouts defined will have cutouts, and all those details, where this can now be sent in a DXF format to the nVent HOFFMAN Mod Center to cut the holes automatically. So no one has to manually drill it. Now, of course, if you don't have the machine, you can also utilize another way, which is for the manual work, is to create a hole chart, which is, again, produced similarly, where you have all the holes marked on the enclosure backplate with numbers and sizes and locations. So you can go do it manually, or you can have it used for programming a CNC machine or what have you. So very easy to take this information and put it out into automated machines to do the layout and wiring. Similarly, you can also create the same information in our DTM and send it to a database or send it to a NC cut machine for the ducts and rails for the PWA 6000. And we have so many more machines that you can send it to, even our partners, even competitors. So those wires can be cut very easily. Now that we've covered that, let's get to the schematic. And we'll do that quick in the interest of time. Schematics are very easy. I'll zoom in to see that. Naming and numbering is automatic. You can, of course, copy and paste with a simple Control C and Control V. But what we'll do is we'll do something from scratch just to give you a better idea or feel for it. Again, what we saw earlier, just simple drag and drop. It'll give it a name based on the numbers of the wire or the sheet itself. And we can add other items in here. So for example, a contactor, let's take a contactor and add that. and it'll connect it automatically together. Let's take a disconnect or a circuit breaker and add that. And maybe a disconnect as well, just mimicking what is there on the top over there. Now, of course, if you don't want to make manual or automatic connections all the time, you can use multi-connect, which can take multiple objects and make those connections and stagger the lines and make that connection. Additionally, you also have the ability to select wires and show it differently. So if you want to show a logic where it says the wires are coming from the bottom here, you can show that in with the click of a button, or change that to you can daisy chain from the top. And the wires will be connected once we start adding wires, which is what we're going to do next. So we have multiple types of wires here. I can go select one. So let's say I'm going to select the 12 gauge black wire, and I'm going to say, okay, let's add that. And what it's going to do, it's going to highlight the wires I'm going to add. So very single line across, and it's added the wires. Now there are multiple wires over there. I'm going to say add one here, go to the next one, add one there, right? So very quick, very easy. The wire numbering is being done automatically, so on and so forth. However, this is because I know that I can add a 12 gauge wire here. Let's take one step back, remove that wire, and we will say, let someone didn't know or accidentally was going to add a 20 gauge wire. What's going to happen? It's going to stop me from doing that, or stop that person from doing that. No wires are being added. You can see an error at the bottom that says this does not match what the wire requirements are for these objects, so it will not let me add it. So that's again a quality check on the schematic side. So it won't let signals collide. It'll make sure that you are not, as long as it's a named signal, it knows if it's a ground or a power, it won't let it cross. And you can, if you select the right wire, it'll continue adding that, finish that. Now, one other thing that I did mention earlier, it's that easy. All the numbering, all the wires have been added, everything is done, and we can sort of start doing other things. And one of those other things might be configuration management. We talked about hey, you can do configuration. It is such a, don't have to do levels or layers. You have to hide and show. What you can do is you can control your schematic with checkboxes and radio buttons, which is, I'm going to zoom in a little bit here. I have the system configuration, which says I have 2 motors, 3 motors, or 4 motors. I've set up the 2 and 3 already. So I can just turn off my second motor from my project, or I can turn off my 3rd motor from the project. And I just added the 4th motor. The 4th motor doesn't have anything on it, of course. And when I do this, I'm not just turning off my schematic, as you might have already guessed, because I've said it a few times, that it's all connected. So a change in one place is a change everywhere. If I change something from the schematic, that should disappear from the enclosure as well, along with the wires. And it does that. I can bring that second motor back, and all the objects that are related to the second motor and associated with the second motor that have set it up are all back as well. So you're controlling your schematic and your enclosure at the same time. But we just added this one, so this has no options. Let's select that and assign an option to it. All I'm doing is saying, hey, what configuration do I want this to belong to? And I'm going to select that configuration and apply that. Now, if I select my 4th motor option, it's gone. And that's the power of this database-driven smart objects, which is you can take information and manipulate it easily. You can save this data inside your project now, and you don't have to design multiple motor control operations every time you have to use them. You can save it in the database and reuse it whenever you need. Now, as a final piece to this is we did a lot of things. We talked about bill of materials. We talked about reports earlier. We can generate them very quickly as well. So I'll give you a quick example of this. You can generate in Excel or other formats, but the report generator is available for you. There are some reports built in already, but they're completely editable as well. So I'll show you a very complex one for now as a simple way of showing. you can do as much as you need to. And you can have cable lists, connection lists, bill of materials, the uh, bill of materials for production, as well as bill of materials for uh, procurement, different types, right? It could be as simple as this one, which is just a bill of materials set up as a simple sample, or you can create one which is very different, has multiple levels and multiple types of information available inside the bill of materials. Again, with the click of a button, it comes in. This is a preview, of course, and you can have all the details that you want to capture about a part already there. So you can have multiple types, and then it can be exported as a drawing, or an image file, or an HTML file, or Excel, which is the most common. Excel and PDFs are the most common outputs, of course. And you don't have to do anything to do this. You have your design already done, and all the data that is happening after that is flowing from design. Now, this is sort of the engineering piece of it. We're connecting to manufacturing one piece. I did mention one more thing in our discussion earlier, which is that we're connecting to manufacturing, giving step-by-step instructions. So I'm going to remove my engineering hat now and put on my manufacturing one. I'm going to go to the shop floor. I'm going to have a tablet in my hand, or a Windows laptop, or a screen on my desk, or like a table on the shop floor. And I'm going to load the application, open up the project. I'm going to say, okay, this is the area I want to wire. I'm going to select my MCC Motor Control Center 1, and I'm going to go to the top shelf. And I'm going to say, okay, that's 86 wires in the top shelf. Submit that and go look at it as to see what needs to be done. And this is the view I get. I get all the information for the wire itself, which is where the wire comes from, where the wire goes, how is it terminated, which pin, of course, what the length of the wire might be, any information for that wire. So in this case, it says connect only destination end. Don't connect this end first, first connect that one. And this is very handy when you're connecting multiple things like doors and back panels. You're going to connect the door objects first, and it's a two-step process, or even three-step process, where you're going to connect all the objects, bundle them together, maybe leave that tied at the end of the door, then take it all and put it in the back plate. So that is a two-step process. You can even divide that into a two-step process. When that is done, you can see it on the screen, of course, in 2D. And if you wanted to see it in 3D, so the choice is yours, you can do that as well, where we can see how the route is in 3D. So the person who is wiring it can see it very easily and has all the details to realize how to wire that. Now, when you're done, all you're doing is clicking a button that says, I'm done. It's going to load the next one, and it's going to complete that. So when I'm done with all this, it's showing you 1 of 86 right now, because we just completed one wire. And if you want to finish the next one and move on to the next one, so on and so forth, it'll keep moving that. So you're able to finish off your wiring similarly. So that is, again, the power on the manufacturing side, where we can do this for wiring now, and we're shortly releasing one for assembly, so you can get step-by-step instructions for assembly, as well as get instructions later on in 2024, information and instructions for testing as well. And the big thing here, another point, final point, is all these wires are great when they're running on the PWM 6000, where they're cut, they're sequenced, they're tied up with a tape. So when you send this into the shop floor, the wires are in sequence, and these lists are in sequence, the same sequence. So when you go to next, the next wire is present in that bundle. You just have to tear the tape off, or pull the tape off rather, and put it on. So very quick, very easy. Customers find that they can reduce, depending on their processes, even up to 80% of the time that is required to look at a schematic, figure out where the wire goes, find the wire, find the length that you need for the wire, terminate the wire, cut the wire, and then install it. Right? That's a lot of processes, and this digitizes that process. So the next question in my mind is, how does this help? Right? We were talking about earlier about two areas, right? One, we were talking about driving what engineering and manufacturing does. The next part I said was improving the efficiency and the driving the growth. And this is the part about that, right? We are trying to maximize the capabilities of potential employees for you. Um, there is another cloud option there, so reduce IT overhead. Again, about efficiency, we're trying to reduce not just the work on the engineering side, but we have some cloud solutions for reducing the IT overhead without actually making it all live in the cloud, right? The design solution is on your computer, so you can travel with it. You can be somewhere remotely without having to have internet connectivity to use the software or to do something in the application, but also have the ability to store stuff in the cloud if you want that. Standardization of projects and automated data and processes. That's how we are helping improve the efficiency. And all those three, the engineering, the manufacturing, and the efficiency improvement, is all driving to the last part, which is profitable growth, be it cost savings, be it time and efficiency and labor savings, be it error reduction, and also, very importantly, helping you digitally transform what you're doing today into the solution for the future. Now, as we wrap up here, there are two things that we can talk about. One is, of course, a summary of what we talked about. The other thing is, how can we help? But when we get started, we want to get started quickly, and we want to do that with support and training for you. So when you join us with the application, there are free training options available, which are self-learned video-based training. There's online community with articles and videos to help you learn again. But after that, the next step is we have advanced training, which is with live instructors, both online and in person. We also provide professional services to create tailored solutions for you, create automation if you need to, or just coach you in how to do this best and to implement it so that you're set up for success. On that note, I'll pass it back. I'm sure we have things that we want to cover. I appreciate your time, and of course, I'm more than happy to answer questions.
Bob, you're up.
All right, so we have one question here. Do you do thermal calculations?
Do we do thermal calculations? We do, well, two answers for that. nVent HOFFMAN has thermal calculation options on our web, which can be done. Inside the application, we have some small calculations available, but I assume, and I'm going to take this further and say, we assume it's about how to select it. And we are working on a more comprehensive solution in the future. Currently, we do some simple calculations.
Okay. Our next question, can a license be shared by multiple users?
Excellent question. The license is based on how many concurrent users. So it's a shared license. It is a floating license. You typically install it on a server somewhere or a computer which can act as a server. And if you have one license, then one person can use it at any given time, but you can have it installed on multiple computers. Once that person closes it, the other person can open it. So it is just how many ever people need to use it at the same time is how many licenses you would need.
Okay. Our next question is, does the software have North American symbols?
Absolutely. It is a global international application. So it has both IEC as well as ANC symbols. And you might have seen it today in our demonstration. Those were, for the most part, all North American symbols.
All right. I got another new question is, do I need a server for a license?
Let me answer that question in two parts. One is, do you need a server? No. Do you want a server? Yes. We typically suggest that you have a server so then everyone can connect. If someone is traveling or the laptop is out, then you don't have to worry about that. But we have customers who use their one computer where it runs the licenses and other people can connect to that licenses on that computer as long as they're on the same network or VPN or anything like that. It is a floating license. And so you need a computer somewhere that other people can connect to if you have multiple licenses. If you only have one license, then you, of course, don't need a server at all.
Okay. Last question is, what are the terms of the DTM software license?
That's a good question. Maybe I need more clarification. I assume, let me say what I understand. Terms, you mean how is it bought or?
Yes, I'm sure. How's it licensed? Is the 1 and 3 year subscription, that kind of thing?
Right. I understand. Yes. So the licenses are so you buy it on a yearly basis. The licenses include support as well as updates for that year. And you have an option to buy it for 3 years as well. Not very different than what you would do for Office 365, for example, right? You can buy it for 1 year, or you can buy it for 3 years, and there's an inherent discount if you buy it for 3 years, with a longer commitment. So those are the two options available: 1 year term for buying the license, or 3 year term for buying the license.
Awesome. And that's all the questions we had.
Perfect. So now, do you have one last slide with contact information on there?
Yes, I do, except yeah.
Well, no, not to worry,
Give me a
Bob.
second.
Yeah, no, don't worry about it. We're going to put up our final slides. Bob did put his contact information in the chat. And if people are needing to get a hold of you, they can certainly contact me or anybody on the CSA staff to get that contact information. I'm sure you're searchable on LinkedIn as well. So I'm sure people can find you if they need to. On behalf
Yes.
CSIA, I would like to thank our speaker, Sanu, for this informative discussion, and also thanks to nVent for sponsoring the event. And of course, thank you for attending. Be sure to bookmark the CSIA events calendar so you don't miss any upcoming events. And that's a wrap. Once again, thank you for joining us and have a great day.
Thank you.